Module 2, problem number 4. Determine the area under the standard normal curve that lies to the left of A, B, C, and D. So we'll go through these one at a time. There's two different ways to do these. I'm going to show you both. Only because, one, I think it's important to understand the standard normal distribution table. When I was in school, in both undergrad and graduate school, we had to use a standard normal distribution table. We were not allowed to use things like Statcrunch. So you are allowed to use it for the assignments and the exam at the end of this session, but it's important to understand how the standard normal distribution table works as well. So we're going to go through both ways for these. So part A says the area to the left of Z equals negative 1.63. First, I just want to take you guys to the standard normal distribution table. This is the one that's in the appendix of that really long path under my stat lab, tools for success, appendices, appendix A. You scroll down until you get to the standard normal distribution table. What I like about it is you've always got this little diagram. This is the same table that's been used for, I don't even know how many years. I hate to say how long it's been since I've been out of school, but this was here long before I was in college. So you have your standard normal distribution here, this little bell-shaped curve. What we're saying is that at this value Z, this is the area to the left of that value of Z in that curve. Remember, when you have standard normal distribution, this is assuming, or you convert it if you have a different number, that your mean is 0 and your standard deviation is 1. So it's always following the same shape and the same size. So that area is standard. So these values in this table down here reflect that area. So we're saying, what's the probability that your value is going to be less than that Z, or that given value? So this one we were looking for negative 1.63. So what you do is you start over here on the left, the Z value, to get the first two digits, that first ones digit and the tenths digit. And then you go up here to the top to get your hundredths digit. So we have negative 1.63. So we're going to go down until we find negative 1.6 here. Then we're going to go over to 3. So we have 0, 1, 2, 3. So it should be 0.0516. So, and here it asks for 4 decimal places, 0.0516. Check answer. Now, before we move on to part B, I want to show you how to do this in Statcrunch. It is very simple. And what's kind of cool is it gives you a different visual, or a more specific visual. So we're going to go to question help, Statcrunch. And then once you're in Statcrunch, you're just going to go to Stat, Calculators. And remember, we're looking at the standard normal distribution. Now, what's kind of cool here, and you'll see this, I posted an announcement about problem number 9. Problem number 9 is when you have different values. You don't have a standard normal distribution, you have just a normal distribution. So that means a bell-shaped curve when your mean and your standard deviation are not 0 and 1. So in this example, here we have a standard normal distribution because it gives you the mean and the standard deviation of 1. So if you don't want to normalize your variable to Z, then you can just change this to say 10 and let's say 3, for example. That's just an example. Does not apply to this problem because we do have a standard normal distribution. I just want to make sure it's clear for when you're working on the other problems. So what it says here too is it already has this less than or equal to. There's also that's the standard, but we also have in between. So when you're saying what's the probability that Z is between, let's say, negative 0.2 and 0.3, you could do this in between. We're going to stick with standard. And see here it says to the left. So we're definitely looking for this shaded red region over here. Now, if we were looking to the area to the right, you would swap this around to greater than or equal to. So we're going to stick with less than or equal to. And we're going to type in that value right here that we were given in part A, just to compare and make sure we get the same answer. So we have negative 1.63. Compute, as you see here, we get 0.05155. So when we round, it's 0.0516. So let's go ahead and do this one for part B. The area to the left of Z equals negative 0.83. Negative 0.83. Compute. And we are given, let's move this over so we can see them at the same time. We need to round to 4 decimal places, so we have 0.20333. We're going to check our answer. Excellent. Now let's go back to our standard normal distribution table just to see that. So negative 0.83. So remember, that means that we need to go over here to negative 0.8, and then we need to go over to 3. 1, 2, 3. We get 0.206, oh, excuse me, I'm sorry, negative 0.83. So we have 0, 1, 2, 3, and that gives us 0.2033, which is what we got, 0.2033. So as you see, you can use the table or Statcrunch. Statcrunch is very quick and easy. I do want to make sure that everyone understands how to read that table. So let's go ahead and finish out the problem, and we'll just use Statcrunch for time's sake. So here we have 0.58. Compute, we're given 0.7190 when we round to the fourth place. Well done. And now we have to the left of negative 0.71. And we have 0.2389 when we round. See that 8 gets rounded up because of the 5. Check answer. Excellent. The other thing I think is kind of cool about the Statcrunch way is that it adjusts and it shows you that shaded region, which might be helpful for anyone that's having a hard time understanding the wording around to the left, to the right, or in between two values. This really gives you a good visual, and it moves it with the values that you're looking at. So that's number 4 for Module 2. If you have any questions, let me know.